what I want you to do is go ahead and get started on that first page of problems. So we're going to do 1A through C. If you need help with C, you are encouraged to look at your notes from Monday or Tuesday. This is not an individual activity. It's a group activity.
The learning target of my lesson today was to get my students to understand binomial probability, and that's based off of binomial expansion.
A family has 3 children.
Yeah, so what's the possibility for child number 1?
Girl.
All right, what's the possibility for number 2?
Boy.
And what's the possibility for number 3?
Girl.
All right, so write that down. What are your
Why
other...
is it girl, boy, girl?
It doesn't matter.
That's it. That's all you're doing.
Boy, girl. Oh.
Okay?
So we have to write down literally?
Uh-huh, literally.
I always open the class with 2 or 3 opening problems that will either set them up for success later in the class or that will bring in a topic that we've already talked about. The way that I try to structure that in my lesson is I want to see a productive struggle with my students. So I want to give them enough information to start grappling with the topic, and I want them to have like small steps of success along the way.
And do we understand what we're doing for part A?
Yeah.
Tell me what we're doing.
So, okay, it says of the given orders of children, how many contain no girls?
Yeah.
So we're going to look at our list and then find which one has no girls.
Yep.
Exactly 1 girl, exactly 2 girls, and all girls.
Okay, so finish up your binomial expansion.
So 1, 2.
All girls.
Where's the third one?
Yeah.
1, 2, yeah. Oh, 3, I got it.
Yeah. And then the last one's 1.
Just 1.
Yeah, because you already have 7.
Okay. So now complete the chart to show each probability for a set of 3 children born to a family.
No girls. That's only 1 with no girls.
Complete the chart to show each probability. No, we had to, it's
Oh,
a
1 out
probability.
of 8.
Yeah.
So everything is out of 8.
The small steps are when they start making the connection to previous lessons. So if you saw in the third part C, I asked them to expand a binomial using Pascal's triangle, which is what we had done previously. And they need to establish the relationship between the 3 children being born, as well as the coefficients from Pascal's triangle.
All right, Ashley's going to come to the front. She's going to explain A, B, and C.
Okay, so the question says a family has 3 children. Use the tree diagram below or list to demonstrate all 8 possible birth orders in terms of whether each child is a girl or a boy. It says expand the expression g plus b to the third using Pascal's triangle. So since it's to the third, I know we have to use up to the 4th line of Pascal's triangle. And then we write out the 4th line, which is 1, 3, 3, 1, and then plus 3g, and then the last one has no g. And then we bring down the b, and then our final answer would be g to the third plus 3g to the second b plus 3g b squared plus b to the third.
Thanks so much. I want you as a group to come up with the relationship between the expanded binomial that Ashley gave you and parts 1 and parts A.
There's a pattern here where it's 1, 3, 3, 1, and then we're using the 4th row of Pascal's triangle, and on the 4th row it's 1, 3, 3, 1. So it's the same.
Throughout this year, we've worked to create a community where people aren't afraid to ask questions, they're not afraid to have the wrong answer, they're not afraid to fail.
The one row that has 3 girls, right? And then the second one has 3 girls. No, it has 2 girls and 1 boy. And then on this one, there's 1 girl and there's 2 boys. And on this one, there's 3 boys. So it's giving us the row of Pascal's triangle, as well as it's telling us how many boys and girls are in every group.
So Alex, can you give us the first similarity that your group talked about?
We're using the 4th row of Pascal's triangle, and on the 4th row there's 1, 3, 3, and 1. And in our groups that we made, we found that there was 1 group with girls, there was 3 groups with 1 girl, 3 groups with 2 girls, and 1 group with all girls. So that's the first similarity.
All right, Tristan's group, you guys talked about that second similarity that you saw. Where do the exponents come from?
So how in the beginning is g to the third, that means that it's girl, girl, girl. And when you look at the chart, it says 1, 3, 3, 1, so it matches the the row of our Pascal triangle, which is 1, 3, 3, 1.
Okay.
And so for exactly one girl, you'll see that it's 3GB to the second, which shows that it's 2 boys and a girl, and you see it 3 times in our list for 1.
Perfect. All right, and so we're going to put some formal notation together for how we already know what the probability is, but now we're going to use binomial probability to calculate it. We're just going to have a more formal way of doing that.
With a scaffolding of those 3 problems, they would be able to eventually see that relationship and set us up to be able to start binomial probability in the formal manner.
The event is having the child, but the probability of having the girl is, write that on your paper.
1 out of 2.
There you go. So Ashley, can you say that louder?
1 out of 2.
All right, so we're going to define the probability of success as having a girl. We also then want to define the probability of failure.
But why is having a girl success and having a boy failure?
Does anybody else want to answer that question?
Success is not having a good outcome, it's having the outcome that you desire. And in this case, we're looking to have a girl.
Okay. Tony Ann, thanks. So is n greater than or equal to r? Yes. Okay. Do our exponents add up to the total? Yes. Yes. Okay. So we have met the requirements that we need. So now we're going to go ahead and put this in a calculator and come up with a probability.
They are willing to ask each other for help and advice and how to move on throughout a problem. And so I've deliberately grouped them so that we do have those conversations.
Do we have to put in the 0?
As an exponent?
It says 3C0.
Yeah.
No. The total is 3.
Okay.
So we're going to put 3. And then 1 is going to be for our
okay.
part.
Tell me why.
Because it says exactly 1 girl. So that's what we want to find. Well, that's what it is, 1 girl.
Okay, keep
so
moving
that's
on.
our part. And then the probability of having exactly 1 girl is, wouldn't it be 1/2 too?
Okay.
As well?
All right. And what's your exponent going to be on that first 1/2?
1.
Tell me why.
Because we're exactly 1 girl.
Okay.
They'll have to go back and forth so that they can eventually get to that final answer, but it's not immediate. We do see like a lot of thought in progress.
The exponent would be 2 on the second part.
Okay, explain.
Because for the probability of failure, it'd be n minus r. And since n is equal to 3 and r is 1, that would be 3 minus 1, which equals 2.
So if you have 1 girl, how many boys do you have to have if the total is 3?
2.
Yeah. So that's why your exponent's going to be 2 on that second half. Okay?
Okay.
So I intentionally structure my classes so that students can leave understanding that the mathematical topic that we've investigated, if we looked at that one day, actually does apply to them outside of class.
And LeBron James makes 74% of his free throws.
I want them to understand that when they read these stats in the newspapers that there's a lot of math behind it, and that's calculated by exactly what we're doing in the class today.
The event here is the free throw. That's the event that's happening. And I want you to quickly think about what's the probability of success on any one shot? What's the probability LeBron makes the shot?
The difference with a Common Core is it does take more time. And if you're looking for a quick fix, that's not going to happen.
So probability of success is what?
37 out of 50.
Yeah.
Why?
Because we took 74 over 100 and simplified it.
What do you want to happen in this case?
You want to make a free throw.
Right, so what's the probability that he makes a free throw?
74 out of 100. So leave it.
So that's the success. What you guys found was the probability of failure with that 37 over 100.
And also, it was a struggle for me because then I had to be patient and wait. And I couldn't say, oh, here's your mistake, or this is where your error is. I had to rely on other students to do that, or to also work on my own questioning to get the students to get the concept that I need them to understand.
Okay, so here, if this is your exponent on this probability, then this should also match, right? Because it's out of 4 shots and we desire 4 shots.
So it'd be 0, 4?
Can you tell me why?
Because it's how many we want. There's no failures.
Okay, so what's going to be, so you still need to include the probability of failure, but what's going to be the exponent on probability of failure?
4? 0?
0 because he's not having any failure. He's making all 4 successful attempts.
The benefits are that if you encourage your kids to become thinkers, that will benefit them throughout their whole, not only their math class, but it's going to encourage them to be better thinkers in their English class, and it's going to be better thinkers at their job and when they go to college.
90% of batteries work and 10% are defective. So if the batteries work, that means it's success.
Okay.
And if it's defective, that means it's failure.
All right, and how'd you get your exponents here?
Because it says all 6 work. So for 90 over 100, that's the success. So that's where I put the 6.
Okay.
And I put 0 for 10 over 100 because it's only talking about the success.
It's not just how to do the math, it's not just how to do the probability, but it's how to become that kind of eternal lifelong learner and lifelong thinker.
I just need to check in and make sure that we are all on the same page for today. So if you can quickly turn your notes over, I have one last question for you to answer that you're going to turn into me. Just to be clear, this is an individual, non-group problem.